Here we have the setup for a simple DC electric motor. The setup consists of a 9-volt battery, some alligator clips and some wires. We have here a copper rotor, which I'll explain further in a second, which is supported by some paper clips. I've bent the paper clips up and they themselves are supported by some blue tack and some thumbtacks. Notice the magnet between the paper clips. I made the copper rotor by winding some copper wire around this handy kitchen tool. You could just as easily wind it around a texter. You wind it round about 15 times, and then you make sure that there are two end pieces which are at 180 degrees from one another. Once you've formed your copper rotor, you then have to scrape the plastic coating off the top half of each of the end pieces. You can do this with a pair of scissors like so. This is so that current only flows through the coil for half a rotation. To start the motor, you simply hook up the battery. Sometimes it needs a little kick, and off it goes. If you wanted to reverse the spin, you could simply reverse the terminals on the battery. What's happening is that as electrons flow through the circuit, they flow through the copper coil and create a magnetic field within the coil. The magnet underneath also has a magnetic field, which, in 2 dimensions, looks something like this. These two magnetic fields interact and create forces, which when current is flowing through the circuit, can attract or repel each other. When current in the coil cuts out, it continues spinning around until the current kicks in again, and once again, forces try to line the magnetic fields up. There are many uses for DC electric motors. This locomotive, for example, has 6 1000-volt DC motors, producing just under 6,000 horsepower in total. 3 of these locomotives can haul nearly 13,000 tonne. And that's a DC electric motor. This has been a G-Up production.